Hello, my name is Leaf. Today I'm going to be showing you my web framework Lapis. Lapis is built on top of something called OpenResty, which is a custom distribution of nginx that comes with a lot of useful modules. One of those modules is nginx Lua, which lets you run Lua as a web application. Lapis uses MoonScript or Lua on top of this module in order to help you build applications really quickly. In order to install Lapis, you just have to run Lua rocks install Lapis. Of course, you'll have to have Lua rocks installed as well. So let's get started. So one of the first things you might run is Lapis. Aside from showing you all the commands that are available, there's one piece of useful information here, using nginx. In order for Lapis to work, it has to find an installation of OpenResty. So this is the installation it found on my system. This is a good way to verify that you actually have OpenResty configured correctly. So if it can't find nginx here, then your OpenResty is not installed yet. Alright, so let's make a new project. I'll make a new directory called sample. It's empty. We'll use lapis new to create all the skeleton files. And then I'll say -git and /tup. So this will give me, in addition to the things Lapis needs, a gitignore file and a tup file, which I'll go over briefly. So this step is actually optional. We're dealing with OpenResty directly now, so you could manually create these files, but I find this is useful and quick. So let's open up an editor and see what it's given us. Let's look at the nginx configuration first. So if you've worked with nginx before, this file might have a familiar syntax to you, but there's a couple interesting bits, namely these variables here. The way Lapis works is that it'll take this file, insert the correct variables, and then compile it down to a different config, which is then sent to nginx. This lets you swap out values depending on where you're running your server. Additionally, a default location at / has been provided that goes to web.lua. If we look at the files that were generated, we'll see web.moon. That doesn't exactly match up, so let's see what happens when we run the server using Lapis server. So by default, this is going to bind to port 8080. So we'll head over to our browser and go to localhost 8080. Server error. Okay, I guess we expected that. And if we look at the log, we can see it could not find web.lua. So if you've used MoonScript before, you're probably familiar with moonc to build moon files into Lua files. But now I'm going to show you how I use tup. So let's kill the server. Let me init git while I'm at it too. So first I'll set up tup with tup init. And let's look at the tup files that were generated. So essentially this is a rule for turning MoonScript files into Lua files. Pretty basic. So if I run tup upt, it'll actually build that file. So let's start the server again. And there we go, there's our welcome message. So here's where tup gets interesting. So let's look at our web application, web.moon. If we were to change this file, we'd also need to compile it to the Lua automatically. It's not fun writing a command every time we change a file, so we'll use the tup monitor. So we can type tup monitor -a. And this will automatically build files as they're changed. You'll also notice I have my terminal back. So let's start the server in the same terminal. And now let's make a change. So here we have a default route of /. We'll just make it say hello. Immediately you'll notice over here that it built the file. So if we go back, there it is. Nice and fast. So in this default application it gave us one route /. Just to give you an example, let's add another route. So we'll add a hello route and it says world. You'll see it automatically builds, and if we go to /hello, it'll say world. Cool. Alright. So let's talk a little bit more in static assets, or a little bit more about tup and static assets. So when I build a web application, I typically like to use CoffeeScript and SCSS, and these have a build step. So SCSS converts to CSS, CoffeeScript to JS. So let's look real quick at our nginx configuration again. You'll notice it also gave us this default static rule, or static location. So everything inside the static directory will be publicly accessible. So let's add a static directory. Just for an example, we'll make a hello.txt and put a little message in it. So now if we go to /static/hello.txt, you'll see our message. Alright, well now let's integrate this with SCSS. Delete this file. We'll add a simple style sheet as an SCSS. And we'll add a basic rule. There's a body, and inside is a pre. Its color is red, and that's good enough. So now we need some way to translate this SCSS to a CSS. So we'll do that by creating a tup file here. And I've got the rules pre-written, so I'll just paste them in. So I've saved my tup file with these rules in them. You'll also notice it can handle CoffeeScript files, which is useful. Anyway, immediately you'll see that it's already built it. So if we go to /static/style.css, it's there. That was easy. And if I make a change to the style sheet, you'll notice it builds automatically. Very useful. Okay, so now how do we get this inside of our web application? So let's go back to web.moon, and let's change this right around a little bit. So instead we're going to use the HTML builder instead of returning a string. The HTML builder is something that lets us write HTML in MoonScript using these auto-generated functions. So for example, I call the method HTML, pass in a function, and within this function I can say something like h1 my header, and there we go, we have a header. And we might make a p tag, and there it is. All right, pretty neat. Let's link in our style sheet. We'll use link rel style sheet. href is static/style.css. And then we'll make that pre tag that we mentioned before. And there it is, it's red. Cool. All right, so let's look at the nginx configuration again. So you notice that as I've been changing the MoonScript file or the Lua file and refreshing the web page, the changes reflect immediately. That's due to this Lua code cache option. So by default it's set to off. And what off means is that every time you make a request, all Lua code is dropped from memory and reloaded. This is great for development. It's really fast. I can make a change, I can see it immediately. This is not so great for production, because what this means is every time I make a request, I have to do all this work. So I'll give a little demonstration. Let's open up a new terminal. Let's run a little benchmark using httperf. So you'll see here with Lua code cache off, it does about 300 requests per second. It's all right, not so great considering it's doing absolutely nothing. So let's change this to on. But there's something important. So we've changed our nginx configuration. So by default, nginx does not automatically reload configurations. Also, this is the Lapis version, so it also needs to be recompiled before it can be reloaded into nginx. So Lapis has a helpful command called lapis build. What this will do is rebuild the configuration and send a special signal to nginx that will reload the configuration side of it without restarting the server. Of course, we could also just restart the server, but this is also a cool thing. Also in production, it's great because you can reload your application without ever dropping any users. So I'll just hit lapis build and let it go. So now the Lua code cache is on, so let's run this benchmark again. Much better. 6,700 requests a second, so that's pretty good. Okay, so you're probably thinking that this on and off value should probably be some sort of a flag, in the same sense that you might notice port and num workers are. So this is a good time to introduce configurations. So every time Lapis runs your server, it's inside a certain environment, and an environment sets these variables based on the configuration. So in order to create a configuration, we'll just create the config module by creating config.moon. Inside of here, we'll import the config helper from lapis.config. So the config helper is just a function, and it looks something like this. You say config, the name of your configuration. I'll make one called production. And then you pass in a function, and this function has a special scope that lets us assign variables. So for example, we might say num workers is 8 and production because I have 8 cores. You'll notice here that this is uppercase and this is lowercase. Lapis will normalize this, but I'll probably change these to be lowercase in the future. So let's create this code cache as a parameter by just using a new variable called code cache. So inside of production, we want code cache to be off, or excuse me, we want it to be on. And then let's make our development configuration. one worker and code cache off. So now you're probably wondering, how do we use these environments? So if you type Lapis and look at the commands, you'll see a lot of these take an optional environment flag. So let's show you how to start the server with a special environment. So down here I'll kill the server, and I'll do Lapis server development. So by default Lapis runs in development mode, so writing development here is optional, but just for demonstration. So now we have our server running development. We can run our test. It's slow, as we expected. Now let's start up our server in production and run it again, and it's fast. Cool. Alright, so now let's go back to development. So you notice I was restarting my server, but if you look at Lapis build, it actually takes an environment. So I can switch environments on the fly, which is pretty neat. Good for testing. So I can just say Lapis build development, and I'm back in development mode. Okay, so now let's look at database access. So if we head over to the Lapis reference manual, we can scroll down to the database access section. So Lapis by default provides the ability to work with Postgres using this nginx Postgres module. Now the way that this works is it actually hooks the Postgres driver directly into nginx, and you communicate with your database via nginx internal requests. So these are actually asynchronous. So if you have a really expensive query, you can actually run it without blocking your web application. Or if you're trying to do more advanced things, you can run a bunch of queries at the same time in parallel. So it's pretty neat. So here are the directions how to set up. Of course, first you'll have to have Postgres installed, and you'll have to create a database. I've already done that, so I'll just jump into these steps. So the first thing we have to do is define this upstream in our nginx config. So I'll just copy this, go back to our config, and add it inside the HTTP block. You'll notice here it references PostgreSQL URL variable. So the next step is actually to create that. So I'll copy this, and I'll put it inside development, because that's what we're working with right now. And I'll have to customize this a little bit. So you'll see PG user, in my case it's Postgres. User password, I don't have one, so I'll just delete that. And my database name is sample. Alright. And lastly, we need to add the location where the queries are sent. So I'll just copy that. And this one goes inside of your server block. You'll notice that this location is marked internal, so this means that no one in the outside world could actually request it. It's only used internally by Lapis, which is exactly what we want. Alright, so now that we have database access, let's do something. But we'll probably need a table to do something, so let's write a migration. So in order to create migrations, we'll create a migration module by creating migration.moon. Now this module should return a Lua table, not to be confused with an SQL table, of functions. So in MoonScript, the last line of a file is actually returned. So I can just return this table here. And each function has a name, so I could say something like hello. And this would be a valid migration, but it doesn't really do anything useful. And I've given it the name hello. Typically, though, I'll use integers as names because migrations are run in a sorted ascending order. And then I'll just let Lua number the entry by default by giving it number 1. So here's our blank migration. So let's bring in our create table and types helpers from lapis.db.schema. And inside of our migration, we'll create a table called hello world. This syntax is explained in detail in the reference manual, but I'll just give you a brief overview now. So hello world takes an array of tuples, essentially of columns. So we'll create a column called ID. We'll use types to make it serial. The types thing is just a helper to generate SQL for us for the right column name or column types. And we'll make another column called name, and we'll use types text. And while we're at it, let's add a primary key of ID. Alright, so we've written our first migration. In order to run the migrations, we just have to just say lapis migrate. Oh, it looks like I made a mistake. Let's see what happened. Oh, I named my file incorrectly. Alright, let's call this migrations.moon, not migrate. So here's something cool. You'll notice I just renamed this file. Tup new to delete the old migration.lua, and now it generates migrations.lua. You'll see this right here. So that's neat. It keeps your directory clean of trash if you ever rename a file or something. Pretty cool. Okay, so let's try this again. Lapis migrate, and there we go. You'll see all the queries it runs. It's migrating. Number 1 is the name of our migration. Runs this query. If we run Lapis migrate again, it'll run 0 migrations. Exactly what we want. All right, so let's try to interact with this table somehow. So let's go back to our web application, and we'll import the model base class from Lapis DB model. And all we need to do is create a new class, hello world extends model. Now the name of this class, hello world, in camel case corresponds to the name hello world in our table. You can customize this in case you don't want this name translation to happen, but this is an easy way to create a model around a table. So we don't actually have to give this any functionality because model has a bunch by default, so we can start using it. So let's create a new route called new that'll help us create new instances of these hello worlds. So we can do hello world create, and then we pass in a table of the columns. So ID is generated by default, so we need to specify name, only a name. And we'll actually use a param from the URL. So we'll do params name, and that returns our thing. And we'll use Lapis's JSON formatter to print the thing out. All right, so let's go to /new. And we'll say name equals leaf, or leafo. Here we go, let's create some more. All right, now we have some instances, let's print them out. So let's edit our view for /, and we can do something like this. An unordered list for thing in all the hello worlds. We can create a list element. That prints out the things. Oops, I created another one. Okay, there we go. There's the 2 cats I created, and leafo and lee. Pretty cool. All right, so let's look at widgets really quick. So you'll notice I've been writing my template using this HTML helper directly inside of my action. This typically isn't a good idea because then your web.moon file might become really large and convoluted. In order to help clean this up, we can actually create views. So Lapis is aware of a special directory called views. So we'll create it. And the way tup works is we need to add a tup file to all subdirectories where we want to build files. So I'll create a tup file real quick. All right, and let's create a view for the index page. So I'll just call it index.moon. So now let's import the widget base class from lapis.html, and then we'll create a new instance of this widget. And we'll define the content method. So this actually uses the same syntax as this HTML builder. So let's just copy all this in. There's one problem though. Hello world here is not defined, but it is defined here. So we could put hello world in a module, or what we can do is we can actually pass the results of the query down into the view. So I'll copy this chunk of code, and I'll assign it to an instance variable called things. And so now from our view, we can reference things and print them out. Now the only thing that's left is to render this view. So we can just say render index. And now let's look and see what happens. Exactly the same. Let's verify that's actually working by making a slight change. Let's change my header to my page. There we go. All right, there's one more little thing we can do. We can actually give a name to this route. So let's call it index. So this is all Moonscript syntax. If you're not familiar, you can look it up on the Moonscript website. But here we're actually creating a table as the key of this field. And we use this to name routes. So now this is called index. So we can just say render true now, and our view's name will be pulled from the route name. So index corresponds to the view we're rendering. I named it index.moon, so it works again. So why is this useful? Well, let me give you a quick demo. Let's say I have another page, /page. I want to link to the index. I can use the URL for helper and just say URL for index. Using the names of the routes, it'll automatically generate the right path for us. So let's make an A tag with an href, and then go to index. So if I go to /page, it works. Cool. So this is a quick overview of Lapis. Hopefully you kind of get an idea of how it works and what's possible with it. I've got a handful of sites running on it right now. It seems to be pretty stable. It works great. It's got good performance, good memory profile. It's great for running in really small VPSs. Hopefully this is interesting. If you'd like to see any more tutorials or screencasts, leave a comment and I'll be glad to help you out. Thanks.